All right, good afternoon, everybody. Once you can hear me, just drop a good afternoon in the chat. And for those who realize it's pretty easy stuff, but it's important for you to know the details of what we would have covered because it's and tomorrow and we're going to read if you remember or remembering it and read through it your own time. Okay, so what we're gonna be doing today, we're gonna be identifying whether two lines are parallel or not, or two lines if they're perpendicular or not. So what we're going to look at is the definition of parallel and perpendicular lines first and foremost, what they look like, what do they mean, and then we're going to do a quick drill identifying whether two lines are parallel or perpendicular. After we finish that, we're going to look at questions that require us to find the equation of a straight line given some information. And we're going to be done with the functions topic. And like I said, we're going to end off with looking at some questions and understanding how to go about answering those questions. All right, so let's start off with parallel lines. Can anybody quickly tell me what parallel lines look like? If you have two lines, right, and they're parallel, what does that suggest? So I have angle slow and that make them have the same. So you have example two lines and that's smaller like arrows. Then you understand this. Lines that you may know those when these lines int. Everybody with me with this one, and this is what we call perpendicular lines. So that's really all you have to remember. At parallel lines, they don't intersect because they intersect and they intersect at 90 degrees. Everybody got that? No. Right, awesome. So down to so we pass everything so a minute. So these are two more important things. Now, all this money gets two lines. Two lines are parallel. So basically what product means again? Which operation presents product? So the product of two things. What are we talking about? Addition, cap. This one is pretty light. Guys, paying exams. That's for the people who are strict with the registration process. So don't wait until it's too late, okay? All right, so let's get back. Are you guys seeing my screen yet? Let me know if you are seeing my screen. No? All right, let's try again. Seen it now? Okay, we seen it now? All right. Excellent. So let's get back straight into it now. So as I was saying, we're going to just write down a different version of the same notes so that it's almost like a summary version to what we have here. All right, you see we're working a lot better now. Yay. Okay, so let's look at parallel lines. So let's say we have the equation of a straight line. So we have y is equal to m1x plus c. So that's the line one. So this is line one. And line two would be y equals to m2x plus c. So if you have m1, which letter represents our gradient again? Anybody remember which letter represents the gradient? There's two specific letters we need to remember. One represents the gradient, one represents the y-intercept. Just a quick thing, what does the y-intercept mean? If you have a graph and the graph cuts the y-axis anywhere, the point at which it cuts the y-axis is what we call the y-intercept. Okay, and that is C. And gradient is just the slope, which we should know already. So if you have two lines, two equations of two lines, if, let me change my color pen. If M1 is equal to M2, then L1, which is line 1, and L2, which is line 2, are parallel. Parallel. So I need everybody to copy down this quick notes here. So this is the first piece of information that really is what the first line discuss. So if you have L1, which is line 1, same thing as line 1. If you got two lines and the first line has this equation and the second line has this equation, if M1 is equal to M2, these two lines are parallel. Everybody with me? So copy this down and let me know when you're done copying down this one. That's two persons done. That's 3. So just to recap, this is easy. Honestly, it's the easier one of the two. If both gradients of the lines are equal, both of them are parallel. That's it. That's all you have to remember, okay? All right, so anybody else still writing and need some time, let me know. Well, we're gonna just move on. No, so this is the conditions for parallel. No, what about, okay, no problem. If you're just looking on tonight, that's perfectly fine. So when it comes to being perpendicular, and I want you guys to quickly, next to this information, just draw two lines with the arrows that just indicates that both of them are parallel, okay? Because sometimes we forget that the idea of parallel lines look like this, okay? So just quickly, just sketch two parallel lines next to it. So when an M put next to it, M1, M2. So M1, M2. And what I need you to do also is put this in brackets in a box so it stands out. Because this is the rule you have to remember. For them to be parallel, M1 has to be equal to M2. Okay, so this is our summary notes. Okay, so everybody should just quickly add that. And now we're gonna move on to the perpendicular line. So like I said, they gave us one rule, but I'm gonna teach you both because it's important for you to know both. I like to teach students all options so that they are strong and aware of all sides. So it says, if you have a line 1, right, and the equation is y is equal to m1 x plus c, line 2 is y is equal to m2 x plus c. And I just want to take this opportunity and remind you guys that the general formula of any line is just y equal mx plus c, where x is the x variable, y is the y variable. So we know input, output, and m is the gradient, and c is the y-intercept. You see how much times I kind of repeating the same things because they are very important to remember. So if we got two lines and we have a M1, which is the gradient of the first line, and we have a M2, which is the gradient of the second line, what did they say? If we multiply M1 times M2 and the answer gives us -1, then those lines, so let me just put, if M1 times M2 is -1, then L1 and L2 are perpendicular. And we should know what perpendicular means. Perpendicular means that they intersect at 90 degrees. So that means this is how these two lines look. So one line will be coming this way and one line will be coming that way. Maybe I should move it a little closer. So let me try again. Yep, like that. and the angles that they both form is 90 degrees on either side. You get 90 degrees on either side. Okay, so that's the two conditions you need to know. Now for this one, there's another specific rule that you need to know. Outside of it being the product and the product being -1, there's another way that you can verify if two lines are perpendicular. It is called the negative reciprocal. Before we talk about reciprocal, don't panic. Reciprocal is another word for inverse. It just means inverse. And we should know what inverse means. Inverse means what? The opposite. So if M1 is the gradient of another, if it is the gradient of the first line, the second line would be the negative reciprocal or negative inverse. I want to teach you both words because if you see it, you should know what both of them means. Reciprocal. So let's do a quick activity to describe what this means. So let's look at tree. What is the inverse of tree? Anybody remember how to find the inverse of anything? You got two versions of it. You can either put it over 1. So the inverse of tree is 1/3. Everybody remember that? Y'all remember we did this? Another way to write this is what? 3 to the -1. So these two things mean the same thing. Remember, anything to the -1 power is inverse. So let's go. If I give you 10, what would be the inverse of 10? Everybody, let's go, let's go, let's go, let's go. What is the inverse of 10? So I need at least 1 or 2 persons to tell me what would be the inverse of 10. How would we write the inverse of 10? Excellent. 1/10 or 10 to the -1. But for this case, we're going to use the fraction version, okay? But I just want you to be aware of the second one just in case for the paper one, they try to like trick you with this version as well. Everybody see that? So let's do another one. Suppose I gave you, oh, look at this. Suppose I give you 1/3. What is the inverse of 1/3? Let me see who's thinking. What would be the inverse of 1/3? Anybody want to try? Guess what the answer is? The answer is 3. The opposite of 1/3 ain't gonna be 3. And I want to show y'all. Hello? I just realized everything got cut out. And I've been here teaching. So let's go again. So let's go again. Let's go again. Did you guys hear my last statement with this one here? With 1/3, the inverse of 1/3 is the same thing as 3. Okay. So let's look at some examples. Let me explain to you why, because I think it's more important to understand why. If I give you a whole number, let's look at 4. How do I write 4 as a fraction? It's a whole number, right? How do I write it as a fraction? 4/1. Agreed? And so if we want the inverse is doing the opposite or flipping it. So the inverse would become what? You realize the inverse would become 1/4? Everybody see why? So suppose I gave you a fraction. But before I give you a fraction, let's look at this one. 1/5. 1/5. What would be the inverse of 1/5? The inverse would be 5/1, which is the same thing as what? 5. Everybody see where you just go straight to 5? The inverse is flipping it. So look at this now. Let me see if you're thinking. Suppose I gave you 2/3. What is the reciprocal of 2/3? Remember that reciprocal means the inverse. So what is the inverse of 2/3? Excellent. 3/2. Everybody see that? So let's try one more. 6/8. What is the inverse or the reciprocal of 6/8? 8/6. Excellent. So when they tell us that one gradient is the negative reciprocal, so let's look at it now. So we're going to do this. I'm going to do a little table and we're going to do a small little drill, because if you could do this, you could answer any questions on finding the perpendicular line of another line. Okay, so let's look at this. The first column, I'm going to talk about a number. Then give you a number. Then you're going to need to find the reciprocal. And I'm going to use this word because I want you to get familiar with it. And then I want you to give me the negative reciprocal. Please copy down this table so that you can have it in your books, okay? Let me use some straight lines so it's less looking like drama. Boom, boom. You're copying down this with me. We're doing this together. Because this is a skill. This is actually something you have to be able to do on your own, especially for paper 1, because sometimes they give you 2 equations and they're going to say which of the following is perpendicular to the given line, and you have to be able to know what you're looking for. All right, so let's look on first and then you guys will copy it down. Okay, so I'm going to give you a number. Let's look at 6. So we know on the side 6 is the same thing as 6/1. Agreed? So what is the reciprocal? Let's go. The reciprocal can simply be what? 1/6. So the negative reciprocal gonna be what? Negative 1/6. Everybody see that? Talk to me if you're with me. So there we go. We keep going. If I gave you 4/5, what is the reciprocal? Thank you. Very good. 5/4. So the negative reciprocal going to be what? Negative 5/4. So look at this now. Negative 1/3. What is the reciprocal? Let me see if anybody thinking. So this is the challenge. What is the reciprocal? Let's take a try. I don't care if you get it right or wrong. I want to see what you're thinking. Excellent job. -3. So what would be the negative reciprocal? If I add a negative to a negative number, what will it become? It's going to become a positive number. So it's going to become +3. So you see, if you have a negative gradient and you want to find a line perpendicular to it, it's going to be positive. Everybody see that? Let's try one more. -5. What is the reciprocal of -5? Let's go, guys. Take a try. Okay, we got -1/5. Anybody agree? That is correct. It's going to be -1/5. And so the negative reciprocal would be what? Remember, the 1/5 don't change. The only thing that changes, remember, this is the reciprocal and this is the negative reciprocal. Don't get confused. You don't find the reciprocal already. Look at it up here. Did we change 1/6 back to 6/1? What was the only thing that changed? The only thing that changed was what? The addition of the negative sign. And here we ended up with what? A negative, double negative, which gave us what? A positive. Excellent. So it's +1/5. You see this concept here? That's the concept that is mashup students. If you cannot grasp this concept, what we're going to be doing next is going to become challenging. So what we're going to do, I'm going to add a few more examples just to make sure we understand. and then we're gonna move on. Okay, so let's try a few more. So let's try 2/3. What is the reciprocal of 2/3? 3/2. Very good. So the negative reciprocal would be what? Negative 3/2. Excellent. So let's try another one. Let's try 9. So let's go. What is the reciprocal? Or let's make it -9 then. So what is the reciprocal? -1/9. So what is the negative reciprocal? The negative reciprocal would be what? Excellent. 1/9. All right. So now that we understand, I hope, Janella, you see why it's now 1/9 is not 9. Remember, 9 was the original, -9 was the original number. We found the reciprocal, and to find a negative reciprocal, all you had to do was add the negative to the reciprocal, and a negative would just change it to a positive. So the actual digit doesn't change, but the negative sign would change. You see that? So let's do a shortcut. Let me see if y'all could handle going straight from a number to the negative reciprocal. Let's see if we could do that. So if I give you 8, what is the negative reciprocal of 8? So let's jump straight to the negative reciprocal. What is the negative reciprocal? Let me just write it above. But before I ask, did you guys copy down the information? I kind of move a little bit fast here. Okay, copy down these examples first, because this is very important. Being able to find the reciprocal and the negative reciprocal. Keep it in mind, it's just another word for inverse. So let me know when you guys finish. Let me know when you guys finish copying down. And once you finish, send me your ranking in terms of understanding the concept of the negative reciprocal. So do you feel like you understand it at a 10, a 9, a 8, a 5, a 3, a 1? Again, I want to point out the role of negative numbers and integers. Like I tell you, most people don't lose marks because they don't understand. Most people lose marks or fail questions because they don't grasp integers as strongly as they need to. All right, so I'm going to show you where the reciprocal is going to come in. So now that you understand what the negative reciprocal means, we're going to look at why we need to know it and how we're going to use it. Okay. Everybody finish? Okay, excellent. I see everybody rank. Everybody finish. Hello, 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 hello. Hello, 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 hello. Can you hear me now? Can you hear me clearly? Can you hear me loudly? It just switched to my laptop mic and not my digital mic. I don't know why, but I'm just gonna talk loudly. So just let me know if you guys are hearing me clearly, and I'll just hold it in my hand. It's so weird. Don't know what's up with that. Okay, can you hear me better now? I think my original, my digital mic is back on now. Okay, good. All right. So let's get back right into it. So as I was asking you guys for the negative reciprocal, I think I saw somebody send it already, but just share it again for me. We're going to go straight into the negative reciprocal. So just to make sure we understand it and could do it directly. Excellent. Negative 1/8. Okay. All right. Let's look at 2/3. What is the negative reciprocal of 2/3? Excellent job, guys. -3/2. Very good. Let's try a -1. What would be the negative reciprocal of -5? It's going to be 1/5. See that? So let's keep going. Let's do 3 more examples until we just get a little stronger. What is the negative reciprocal of 4/6? -4/6. Masterpiece. Anybody else? Excellent. Positive 6/4. And as you realize, you're going to realize it's always the opposite sign. So if it was positive, it's going to be negative. If it was negative, it's going to be positive. So let's try one more. -4. Excellent. Anybody else? Very good. Excellent. 1/4. Positive 1/4. So let's look at how this information is now useful. So just to touch base, remember, if 2 lines are parallel, what? They both have what? It's just simple. M1 is equal to M2. Are you? I can't find nothing. Where everything gone? Okay, look at here. Is it this? Okay, yes, look at here. Oof. So as we were saying, if 2 lines, so we already know the first condition is where. So you can look at this version where if you multiply the two gradients, the answer is going to be -1. But suppose you get one of them. You see how the other example is? You can guess the second gradient because they're equal. So if they give you line 1 and they ask you, well, if 2 lines are parallel, what would be line 2 gradient? You could say it's the same thing because they're equal. So you could use one to find the other. In this case, you can't find one to use the other because you need to multiply both of them to find -1. That means you need to be given both of them. So how do I use one to find the other? So like I said, M1 is the negative reciprocal of M2. So that means M1 is equal to negative, not M1, M2, sorry about that. M2 is equal to -1/M1. And what does this mean? Once you know the first one and you find the negative reciprocal of the one they give you, you get a second one. Because all this represents, this is a symbol or equation version of saying negative reciprocal. Everybody see that? This just means the negative reciprocal, and that's what we've been finding the whole entire time. So please copy this down. So it's two things you could use. If they give you the two gradients, if you multiply them, you get -1. That's how you prove that both of them perpendicular. But suppose they only give you one. You could use the negative reciprocal method to find the second gradient. That's all. So this way, you got two ways to look at it and two ways to determine if it is positive or not. And I want to show y'all something. So take a pause. Look at this. Let's take this equation. M1 times M2 is equal to -1. If you want to find out, if you want to make M2 the subject, how do we get rid of M1? Anybody remember? This is solving. So if I want to put M2 in front alone and say what M2 is equal to, how do I get rid of M1? All of this is algebra again. Excellent. You do the opposite. Remember, to get rid of something in an equation, you do the opposite. So here we are multiplying M1. So to get rid of it, what we're going to do? Divide. When we divide, what's going to happen here is going to cancel. Whatever you do to one side, you do to what? The other side. So what are you going to end up with? M2 is equal to -1 over M1. That ain't what I give you down here. That ain't the same equation here. Everybody seeing this magic? Let me show you. So look at the proof that explains why we could use this to get that. So let me just circle it. So this is the proof of this equation here. Everybody seeing it? So we took this equation, the original equation, and we solve for M2 to give us the second equation. I know it's a bit advanced, but I think you guys can pick up on it, or at least understand. It's for you to just understand how we get this formula, because it's important for you to understand how we got the formula. But everybody seen it? Just confirm. If it's no, it's no. But let me know if you're following what I just do to show you how I get this second formula. All right. So let's now get into the actual meat of today's class. So now we know two things. If the gradients are equal, what happened to the two lines? They're parallel. If the two lines, if you multiply the gradients and you get -1, they are perpendicular. Or if they are the negative reciprocals of each other, they are perpendicular. So let's look at some examples. So I need you guys to let me know if you finish copying these things down. You don't need to copy down this here. This was just me explaining why. But what you do need to have is this part here. All of this down here, which is this here. So make sure you have the two formulas. M2 is equal to -1 over M1. And we don't know what M2 and M1 is. It's the two gradients from the two lines that they gave you. So let me know when you guys are finished, and we're going to look at some questions, and we're going to determine if the two lines are parallel or if the two lines are perpendicular. I know we're moving a little bit fast, but I want to make sure I teach you guys as much content as possible. So when we start to practice past paper exams, I can always say, okay, guys, we did this on this date, etc., etc., etc. All right, so I'm going to open up a fresh page. Let me see. Music in my ears. I don't know. Okay, everybody finish? All right, so let's take a look. Let's take a look. Let's take a look. So we up here now. So let's start off with the first two. We're going to start easy, obviously, and then we're going to get harder and harder and harder. So this is the instructions. Determine if two lines, let me just put two lines, cut down this thing. Two lines are parallel or perpendicular. Please copy these down. Or neither, because sometimes they're neither perpendicular, or neither. So it's either one of the three. And that's in general. It can't be nothing else. It's either two lines gonna be parallel, They're going to be perpendicular or they're not going to be either. Okay? So we're going to look at question 1. So let's start easy. Y is equal to 3x plus 4. Y is equal to 3x plus 7. So how do you prove or how do you determine? What must we state? We must identify the two gradients in it. So the first thing you must say is M1. What is M1 here? Remember, M is always the number right in front of the X. And we don't have nothing in front of the Y. So we could take that directly because it looks like our equation, right? So let's get that straight. Before we do anything, we must make sure that our equations look like this. Y equal mx plus c. Nothing in front of the Y, something in front of the X, and plus or minus a number. Everybody with me? Because this is the general equation of a line. It must look like this. So that's the first thing we need to check before we do anything. Both equations look exactly like that. There's nothing in front of the Y, there's a plus something in the back, and then there's something in front of the X. So we want to find out who. We need both of the M's. So M1 is what? In the first equation, we get it from the first equation. So M1 is 3, and M2 is what? M2 is how much? Look at the second equation. So the first equation gives us M1. The second equation gives us M2. And so our M2 in this example would also give us 3. So what would you say? Since you literally have to learn how to write your answers in math, you have to communicate. So you have to say, since M1 is equal to M2, therefore, that's what these 3 dots mean. Learn to use it. Therefore, the lines are what? What are they, guys, since they're equal? Are they parallel, perpendicular, or neither? I only seen one person talking to me, one to everybody else. Let's go. You have to learn how to identify these things by yourself, and I hope you guys are also copying them down. Therefore, the lines are parallel. Everybody see how easy that is? I remember from our last class, we were able to identify who is the M's, who is the C, etc. So everything coming together now. So let me know when you guys are finished copying down this one. So this was example 1. Okay. All right. So let's look at example 2. Should I get a new page? Let me get a whole brand new page. Let's get a brand new page. Let's get a brand new page. So let's go example 2. So let me use green and write the equation in green. So example 2, write while I write. So I'm going to give you the 2 equations. Y is equal to negative 4x plus 1. Y is equal to 4y is equal to negative 16x plus 12. So this question for me now, let's discuss it. Can I look at this question and pull out, is this a direct question like the last time? So why would I call this a direct question? Let's take a look, because I need to teach y'all how to see and how to determine what you need to do first. This is considered a direct question. You know why? Because the equations were already in the standard form. So that means I could have looked at it and pull out my M's without changing anything. Everybody see why this was direct? Let's look at the next example here. Is this a direct question? No, because what is wrong here? What makes this an indirect question? What throwing off the entire thing? There should be what? There should absolutely not be any 4 in front of the Y. So what do we do to get rid of the 4 in front of the Y? You see algebra again? what do we do? What does 4y mean? 4y means 4 times y. So if we want to get rid of the 4, we divide by 4. Do I only divide by 4 here, or do I have to divide every single term by 4? So everybody gotta get divided by 4. Every single body gotta get divided by 4. Very good. So what's gonna happen here? This gonna cancel and give me 1. So let's rewrite our equation. What are we gonna end up with? So we're gonna end up with, let's rewrite the first equation. The first equation was y equal minus 4x plus 1. So what would our second equation become? It's gonna become y is equal to what? Negative 16 divided by 4 will give me what? See, integers again. What will this answer give me? A negative number divided by a positive number will give me a negative number. And 16 divided by 4 is 4. And then we put back the x, and it's going to be plus what? 12 divided by 4 will give me what? Excellent. So, can we now find and determine if our two lines are parallel or perpendicular or neither? Can we now approach our question? Yep. So let's go. So let's find M1. What is M1? M1 is equal to how much? Excellent, negative 4. And what is M2? Same thing. So what do I write now? Do I just write the parallel? No, I have to say something first. I must tell the examiner that I know the rule. And what is the rule? I'm going to say since M1 is equal to M2, therefore, the lines are what? The lines are, somebody help me. What are the two lines? They are parallel. Excellent. Everybody see that? Everybody with me? Remember, we did this last class. We did this in a class where we had to change certain equations back to the regular standard form. You see where that skill is coming in now? So I hope you guys realize everything we did before is now coming towards this very point. It's helping us do these things a lot easier, a lot faster. All right, so let's do, let me know when you guys are finished copying down this example. We're going to move on to example 2. Okay, excellent. So let's move aside. Let's look at these two examples now. Example 3. So let's go, my awesome people. Is this a direct or indirect question? That's the first thing. So do we need to change anything, or we could just pull out our M's? Excellent. It's direct. No, it's direct. Look at it. There's nothing in front of the Y. There's something in front of the X's, and then there's something behind here for the C. So what we're going to write now, M1 is equal to how much? Excellent. M2 is how much? So what is it, guys? What would you say now? Are they parallel? Are they perpendicular? Are they neither? Let's see if anybody thinking. Okay, so Myrtle said neither. What about everybody else? What do you think? Excellent, they're neither. Because, and how would we write this? We're gonna say since, just like how you could say they're equal, what you can say also, you could say that they're not equal. So you could say since M1 is not equal to M2, they are not parallel. Agreed? And And you want to prove that they're not perpendicular, right? So then you would say, and M1 times M2 is not equal to -1. So they are also not what? Perpendicular. Because if I multiply them, I should have get back -1. But 2 times 5 is 10. That's not -1. So that means they are not perpendicular. Everybody see that? Usually students will just leave this and write nothing. If you do not communicate that you know that they're not perpendicular, that they're not parallel, you don't get no marks. You have to tell them that you know why. You have to give them an answer and you have to say you know why. And the reason is because they're not equal. And when you multiply the two of them, you don't get -1. And another way you could say it is that one is not the negative reciprocal of the other. All right? Everybody with me? Pretty straightforward, right? We're going to do another one. And let's see if we could pick up on this. Because like I said, this is still easy stuff because it has a lot more complicated version. But once we understand the basics, we can then develop our understanding from there. All right, so let's try 2 more. And then we're going to move on to the equations, finding the equations using the same information. So you guys finish copying this down? Okay, also just a heads up, this week I'm gonna start sending you guys some practice papers, exam past papers on question 1, question 3, and question 4, because we've done those topics and it's to keep you fresh. So that's things like fractions and decimals and significant figures and algebra things. So please try as hard as you can to make time to study and revise. Okay. All right. So let's look at example 4. And as you guys know, we got class every day this week because we're trying to do as much as we can in the December so that when January come, we're not stressed out about doing too much. All right. So next question. Let me see if you guys gonna get this one. Example 4. Okay, somebody just asked me if the extra classes are for an additional fee. No, guys, they are not any additional fee. It's the same fee. It's just that I need to give you guys more time when I cancel school closing. So it's the same cost for the month, no additional fee, okay? Don't stress yourself, man. Just show up to class. That's all I need you guys to do. Show up to as much classes as you can. All right, so here's example 4. So first question I'm gonna ask you, direct or indirect? That's the first question. Direct or indirect? Anybody else? Excellent, because remember that's the first thing you have to look at. You can't just jump and look for M before you realize or identify if it's set out the way it's supposed to set out. And I'm going to write the equation again because this is something we have to memorize. Y is equal to mx plus c. So let's go. What is M1? What is M1, guys? What is M1? Excellent. -1/3. What is M2? 3. No, we could look at it because of our skills, because we understand the concept both ways. We could look at this and identify what? That -1/3 is the reciprocal, the negative reciprocal of 3. But because they gave us both of them, which law you think we got to use? We got to use the product law. So we must say, since M1 times M2, but let's prove it. Is that true? So let's come on the side here. Let's prove it. -1/3 times 3. And what is the same thing as 3? 3/1. Everybody see that? Everybody see how I get 3/1, right? So let's cancel it now. 3 into itself goes once. 3 into itself goes once. So what we're going to end up with? -1 times 1, -1/1, which is the same thing as -1. So that means that since M1 times M2 is equal to -1. Therefore, both lines are what? Both lines are what? Perpendicular. Yeah, you know the word, perpendicular. So everybody see an example of identifying two perpendicular lines, but this is an easy one because this was direct. So let's see if we could handle or manage another question that may not be so direct. Let me see if I can mash it up now. Let me see. Let me see. Let me see, let me see, let me see. Let me look for one that's hard. Let me look for one that's hard. Yes, I have one. So let me know when y'all finished with this. Maybe only love. Okay, awesome sauce. Anybody else still writing? Let me know. Somebody calling me unknown. That's weird. Okay, everybody finish? So let's take another example. Example 4. How you guys feeling about what we're doing currently? Let me quickly check in with you guys. Let me see how y'all feeling. Example 5. Okay, thank you. How are y'all feeling so far? Feeling 9, okay? What about everybody else? How y'all feeling? Y'all managing, y'all understanding, y'all following? Feeling 8, 7. Okay, feeling 9, okay? Okay. All right. So let's look at this one. No, I'm telling you no, I need you to pay attention to this one. +2. Okay. And then you're gonna have x plus 7y equals 8. So first question, direct or indirect? This is how, I'm gonna be honest with you, this is the type of question CXC gonna bring. So if you can maneuver around questions like this, you're in a good place, okay? So we say indirect. Everybody agree with that? Let me know. That is correct. Which equation needs to change? The first one or the second one? Excellent. Okay, so my next question is, what's the first thing we need to move? Because what is one thing we need? We need y to be in front by itself. So before we deal with the y, what must we get rid of first? Remember what I taught you. You can't touch the y yet if they got another thing on the end. Who need to go first? No, the x. Because look at it. We want it to look like this, right? Y equal mx plus c. The y is on the correct side. But who on the wrong side? The x ain't supposed to be over here. So we cannot get rid of the 7 yet until we get rid of the extra stuff. Now, next question. How do we get rid of the x? Anybody remember? Because we are adding, what can we do with the x? We can just move the x over. And when we move it over the equal sign, what is going to happen to it? Anybody remember? It's going to become negative. Excellent. So what is going to be left back? We're going to be left back. You take it step by step. We're going to be left back with 7y is equal to 8 minus x. Everybody see that? I have a question for you. This is outside of what we're talking about. What is the coefficient of x here? Let me see if I gotta fight anybody tonight. Okay, Myrtle. Okay, not excellent job. I thought I was gonna get sad tonight. Very good. So we know that a one is an invisible one is here. Very good. Let's go now. What do we do now to continue to fix the equation the way we need it? So now that we clear off everything else, we only left back with 7y. So now we could deal with the 7. What do we do to get rid of the 7? Excellent. Divide by what? So everybody gotta get deleted by 7, divided by 7. Everybody see that? So what's gonna happen here? This gonna cancel. So watch this now. This is something I want to teach you guys now, right now. So what we gonna have left back? Y is equal to 8 over 7 minus 1 over 7x. Isn't that true? What did I just do there? What did Miss V just do there? Let me go over on the side here. I broke up this 7 over x. I mean 7 over x. X over 7 minus. And the same thing as saying 1 over 7 times x over 1. Anybody realize that? Because 1 times x is x. 7 times 1 is 7. So you could always break up something to look like this. So another example, m over 3 is the same thing as saying 1 over 3 times m. Because remember, this means to divide by 3, eh? Y'all know that, right? Everybody with me? So this is just a side note, a by the way, that these two things mean the same thing. Everybody got it? So let me ask a question here now. So I'm going to rewrite my two equations. The first one that didn't need changing, which was y is equal to 7x plus 2. What do you realize about this as well? Before we even do there, what you realize here? Anybody realize anything here? Who is C and who is the M? Remember, even though this is scrambled, it is the same thing. This is going to be my C. Remember, the number is always C. And the number in front, the X, is always what? M. And because this sign is negative, M is going to be negative, right or wrong? So I could rewrite my equation like this. I could rewrite it as y is equal to negative 1 over 7 x plus 8 over 7. Let me know if you see it. All I did was switch these two so that the x thing look like this. Y equal mx plus c. Tell me the truth. Tell me if you see it or you see it. Everybody, every single body, let me know if you see it. So one person has 2, that's 3. Ajani, you see it? It's almost like me saying y is equal to 4 minus 3x. All right, realize that? It means the same thing as y is equal to negative 3x plus 4. These two things is the exact same thing. All I did was switch them. And not because we're dealing with fractions mean the rules change. It's the same concept. So let's get down to the nitty-gritty. Now that we have what we need, let's go. What do I need to find now? Who is M1? M1 is what? Where the X come from? Remember, M is just the number. So M is just 7. What is M2? Excellent. Before us proving anything, are these two lines parallel or perpendicular or neither? Excellent. The perpendicular. So all we're gonna do now, is just write down our proof, right? I'm gonna zoom on so you can copy down everything. So how do we write it again? So we're gonna say since M1 times M2. And remember, you could always go on this side and prove it, like multiply them to back check. But I already know it is because we already know it's the negative reciprocal. So since M1 times M2 is -1, then both lines are perpendicular. Let me zoom out now. So that was example 5. Let me know when you guys are done, okay? Okay. All right. So now that we generally understand the two concepts now, we understand how to identify whether two lines are parallel, whether they're perpendicular or they are neither. Now we're going to have to learn how to generate an equation from 2 points or from another line. Okay, so that's the last thing we're going to do today. Once we complete that successfully, we are done with functions and relations and graphs. Because I would really like tomorrow's session to be us going through past paper questions and just getting accustomed to the way that questions come and how to analyze it and all these good stuff, okay? So let's just get back to notes, because you see, I kind of basically taught you guys without the notes. So you have the notes as reinforcements. Let me see. I think it was this one. Let me zoom out. It was this one, yep. So these papers here have their own examples that you could use and go through on your own. All right. So you see, they give you an equation and they say, okay, 5 is the gradient for the first one. The equation is parallel because the both of them have the m as 5. And then you see the same thing here with m being the negative reciprocal. When you multiply both of them, you get -1. So all these notes you guys have in your handout. Let's look at this question here. A straight line PQ has an equation here. Determine the gradient of any line that is parallel. So this is the type of questions that has come. If they give you this, what's the first thing you have to identify? So they give you this equation. Y is equal to 4 minus 2 over 3x. So my awesome people, what would be M1? What is the gradient of this equation? We should be able to pick it out because we just look at it. Is it positive 2 over 3 though? What does the regular equation look like? Y is equal to mx plus c. Everything should be positive. So if there's a negative here, that means m is negative. Everybody see that? So m1 is equal to what? -2 over 3. So that's the answer. Because if they're parallel, m2 gonna be what? The same thing. So you see how you would answer a question like that? So this says, determine the gradient of any line that is parallel to PQ. So the gradient of that line, M2, is -2 since, and you would put what? Since M1 is equal to M2 for parallel lines. Everybody with me? So you see how we use the same concept that we learned to answer questions that are varying. You realize the wordings are sometimes different. These are the important things. No, I love this second question. Find the gradient of a line that is perpendicular. So now that we know M1 is equal to -2 over 3, what would be M2? You see where the skill is now? What is the negative reciprocal of -2 over 3? Somebody, let's go. Because if the gradient is perpendicular, we know it's the negative reciprocal, right? So what would be M2? Is it negative 3 over 2? Remember the answer was negative already, you know. So if we make it, if we add another negative, it's going to be positive 3 over 2. Everybody with me? Everybody see how we answered those two questions? So you realize how we use the information from one line to determine information for another line. So if the next line is parallel, it's equal. If the line is perpendicular, it would be the negative reciprocal. All right, let's look at the other slide. We almost done. So look at here. See? Negative reciprocal, blah, 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 blah. All of this is in your notes. You have this already. Okay, we did this last class. For those who were not here, please look at the video that talked about calculating the midpoint of a line, the length of a line using these formulas. We did it already. The only way I will go through this is if you message me one-on-one and you need help because you didn't understand. No, we're going to do this, and this is where we're going to end class because that's it. Okay, because we're going to try to finish today. Finish today. So we're going to learn this concept here. Finding, so this is your new topic. So please write this down so that you know that this is our last topic. Finding the equation of a straight line. And there are two ways that they could ask you to do this. So let me zoom in. So the first way they could ask you to do this is by using 2 points. They're going to give you 2 points and they're going to ask you to find the equation of a straight line. Given 2 points. So everybody, eyes up. Let's follow this example because it's pretty easy. Now, 2 things I want you to know. What is the general equation of a straight line? All of it must look like this. You see, we're going back to this again. Y is equal to mx plus c. What are the 2 things that we need? We need to find out what m is, and we need to find out what c is. For those who were here last class, the formula for m, which is the gradient, is this. Y2 minus y1 over x2 minus x1. So there's going to be a small recap for you. In the first example here, they gave us 2 points. So let's look at the 2 points they gave us. They gave us L and M. Remember, for every point, you always have what? The first number is always X. The second number is always Y. Everybody remember that? So because we got 2 points, we need to label the different X's. So this is going to become X1 for Y1. And for the second point, there's going to become X2, Y2. So before I continue, everybody realize how I label each coordinate. So you have your first point, which is L. That's why it's X1, Y1. And then your second point, M. That's where you end up with X2, Y2. Talk to me. If you don't understand, just make sure you go and look at the video that we did last class to kind of like help you with this part. All right, so we're moving along. So now that I know my values of X1, Y1, X2, Y2, guess what I'm going to do now? I'm just going to put it in the formula. What is the formula to find gradient? Look at here. So M is equal to this. So let's go. Somebody, who is Y2? What do I substitute for Y2? Which value do I substitute? Is it 4, 6, 10? Which one is it? Who is Y2? Excellent. Y2 is 10. So it's going to be 10 minus, because look at here, Y2 minus Y1. Who is Y1? Y1 is 6. Excellent. So it's 10 minus 6 divided by, what is X2? X2 is the next 6. Very good. 6 minus X1, which is what? 4. Very good. So you work it out. 10 minus 6 is 4 over 6 minus 4 is 2. So what is my gradient for that line? The gradient is what? 4 divided by 2 is 2. So that means m is equal to 2. So guess what? We have this information to plug in. So now our equation would look like this. Y is equal to 2x plus c. Who we missing? We're missing c. No. Remember at the beginning of graphs, we learned 2 equations. This was the second equation that I told you we're going to need only for one situation. Remember, we spoke about 2 equations, but this one is the most popular one. And this was the second one that we didn't use up until now. So you see this equation here. Everybody write it out, please. This is the second version of the general equation of a straight line. You have to memorize this as well. But you see, you're going to know when to use one or the other. So it's both of them. The first one, this is the one that we use the most. Y is equal to mx plus c. So this is the first one. And the second one is this one. Y minus y1 equal mx minus x1. Everybody understand? Please copy this down just like what I was saying. And this is the equation, general equation of a straight line. Let me know when you're done. I know this is a lot, but as we get into the questions, you're going to realize again how easy and simple it is. It's all about us just getting the content and being aware of everything possible that can come and then applying it to questions. And then we're going to end class right here after we finish these 2 examples. Okay, 2 persons saying they're finished. Okay. So before we continue, everybody understand what I'm showing you? Like, even though now I'm reintroducing the second equation, I hope you understand when we're going to need to use it. So the first one is the one we use generally. You realize how much time we made reference to it, how much times we use it. And now we're going to be using the second one. And what are we using it for? We are now creating the equation of a line using 2 points. So like now we got to create the equation from scratch. So before, they gave us the equation and we picked out information from the equation. So we were able to pick out the gradient. We were able to determine whether it's parallel to something else. All of these things we were able to do when they gave us the equation. Now is that we're going backwards. They're giving us 2 points and they're going to ask us to find the equation using the 2 points. I hope everybody understand the difference. So first, we use the equation to find information. Now we're using information to find the equation. Everybody with me? That's how you should store the information in your mind. So let me know if you understand that's what we're doing now. Okay. I hope everybody else got me too. So let's look at this. Let me just erase this because all I did was just rewrite all of this that's already here bigger so that it could stand out. All right, so let's take a look at this. So you realize they calculated the gradient because you're going to always have to calculate the gradient, okay? Especially if they give you the 2 points. We did that on the side here using the equation. They just did it straight. They didn't put the formula. And for me, I make it mandatory. You always, always, always write the formula, because what you're going to tell, that's the difference between a grade 1 student and a grade 2 student. That's the difference between a grade 2 and a grade 3. Because when the person marking your paper, they're going to be like, well, where you get these numbers from? But if you tell them that you know y2 minus y1 over x2 minus x1, even if you make a mistake and put the wrong number, they're going to still give you some marks because they realize you understand that that's what you should be doing. Everybody with me? All right, so there we go. So we calculated our m. So we know m is equal to 2. So now we're going to use our second equation to determine the equation of the line. So you realize what they started off with? They always start off with a general equation. Now from this, we're going to use the first point. So let's go. We know what m is because we calculated. So that's what they substituted here. And you realize they chose the first point. So that's why we use x1 and y1. So where y1 is, what did they put? 6. Everybody see that? Where x1 is, what do they put? 4. Is that correct? Yep. And what do they do next? So I'm going to copy all of this down and work it out for you so you could see. So you have y minus 6 is equal to 2x minus 4. What did you learn to do first anytime you have anything like this? What is the first thing you should attack? What is the first thing you should attack here? If you was to solve this. Remember BODMAS? BODMAS means what? Brackets, right? So what does the brackets mean here? The brackets mean to multiply everything outside by everything what? Inside, right? So we're going to say 2 times x minus 2 times 4. So let's write back everything that we didn't use. So we're going to put back y minus 6 is equal to 2 times x is what? 2x. Everybody see that? Minus 2 times 4, 8. That's how they get here. Everybody tell me you got it before we continue. So you now know how we get from here to here and to here now. All right. So we want our equation to look like what? Because don't forget, even though we're using this form, what do we always want our equation to look like? We always want it to look like y is equal to mx plus c. So you realize we still had to use the first one because this is the general equation, the most popular one. That's what all our equations must look like. So what do you need to get rid of, guys? Who need to move then? Who throwing us off? Who should move? Look at it. Tell me. Janella says, okay. And keep in mind, it's not just 6. It is negative 6. And when negative 6 move over, what gonna happen? So what we gonna end up with? Y is equal to 2x minus 8 plus 6. So we see how we get here. And now, what rules is this? Integers. So negative 6 plus 6 can give me what? So we're going to end up with y is equal to 2x minus 2. And this is the answer. You realize this is really just algebra? So it's about remembering the formula and doing the algebra. Everybody see that? Let me know if you see it. You see why we spent so much time on algebra before? Because if you cannot solve, if you cannot transpose, you are going to struggle with every topic. Everybody see that? So that's it. Guess what? That's it. That's all. That's literally it. So the second one, in this example, the thing freezing. Is this a sign? Is this a sign? All right. So this second one, we're just going to read through it. And what is the second case is? Generally, says, I say we almost done. This is the last one and we done. So case 2 is when they give us the gradient and a point. So what do you realize here? Luckily for us, do we need to calculate M? We don't need to calculate M. And they give us the point. So all we had to do was what? Do the original equation, which is y minus y1 is equal to m x minus x1. So all we needed to do is use our general equation, substitute m, boom, substitute our x and our y. And we know x is 4. You see, that's why they put it here. And y is 3. That's why they put it. Where did they put it? They made a mistake. Anybody see the mistake they make? Let me see if I see the mistake they make. What's the mistake they made here, guys? They made a huge mistake. Who could pick up on the mistake they make? Let me zoom in. What is y? Let me use red. You realize x is 4 and y is 3. But what did they put here? What should be here instead? They're supposed to be a 3, so they made a mistake. So let's do it over. So what we're gonna end up with now is you see why it's important to pick up on things? Because these things happen. People make mistakes. That's okay. So you end up with this minus 4. You know why I love this question? Because it's complicated. This is a very difficult question. So if you can handle this, you can handle anything else. You know that, right? So let me go. So we're going to focus on what? Brackets, right? So y minus 3. If I multiply 3/4 by x, what am I going to end up with? 3/4 x. But look at this now. If you got to go to your side and work it out, please do that. 3/4 times 4 is the same thing as saying 4/1. Everybody see that? So cancel, cancel. What you're going to end up with? 3 as a whole number. And because it was minus, it's going to be minus 3. Everybody see that? Everybody see that? Let me know if you see it. Let me know if you see it. So there we go. So now that we have this, same thing like before, we need y by itself. So we need to move this over. When we move it over, what's going to happen? We're going to end up with y is equal to 3/4x minus 3. When the minus 3 go over, it's going to become what? Plus 3. Negative 3 plus 3 going to give me what, guys? 0. So y is equal to 3/4x plus 0. I only put the plus 0 so that you could know that this is the value of C. That means that this graph cuts right here in the origin. That's why it's 0. So the y-intercept is 0. Everybody see what I mean? What is the gradient here? What is m? So m is equal to 3/4. C is equal to 0. So this is the equation of the line. So guess what? That's it for today's class. So the only thing I need you to remember here, don't worry, we're going to practice some more next week, is remember this equation here. And next class, we're going to look at some questions where we use it. Please know that you have this document so you could go through it on your own. But that's it for today's class. We did a lot. So overall, based on what we did today, how you feel about it? Even if you don't remember everything, how you feel about what you did? Did you understand? So that's what I need to know. How much do you rate your understanding? Eight and a half. Okay. 8.5. 9. Alicia, where you at? How much you rate yourself? 8.5. Okay, that's excellent. Okay. So no homework because we got class tomorrow. We're gonna practice the questions. So that's it, guys. I'm going to upload this video for you guys to have to look over if you need to. But that's it for today. See you guys tomorrow at 6 p.m. Okay. If you can't make it, just let me know. Have a good evening. Bye.